Right. So today we're going to start with, let me start with math practice for ha-has. Good afternoon, y'all.
Good afternoon.
Comes Joanne.
Oh,
All
we're
right.
being picked up right now.
This is what I have so far in terms of the progress. No big deal. It's just that you don't want the reds to pile too far because we're going to start getting into some some descriptive statistics and some normality tests. And I think the successful people have gone through pretty easily. It's just try to do it like regularly and don't get too far behind. So that's what I have so far. If anybody got me something that I missed, um, please let me know. But I think this is what I had for homework for the 14 principles quiz. Everybody did
Bill,
really well on it. Of course,
I'll resend my 14 principles because I emailed it to you
you did.
the other week. Yeah,
Okay, you know what? I was looking for it, John, and I didn't see it, but I do remember seeing it. So how's that?
looks good to me.
Yeah, because I definitely remember opening it, and then I'm like, man, I don't, how come I don't have John checked? So I got to do some lean on my own processes. It's the issue. So today, what we're going to cover, we did the Pareto homework, 14 principles. Today, we're going to get into a couple. The homework's going to be to do a what we call a SIPOC, and maybe you guys have done them before. Um, there comes Paris. And largely, you start with process, and then basically you list up from that process. You list the outputs and what the customers are getting, and then you work backward, inputs and suppliers. And example is this is from Dan Rakowski. You guys probably know him, the Oprah guys. He did one on drinking at the bar. Going to the bar, my output's an empty glass, bar patron, finding a seat, ordering a drink, injection molding of plastic parts. This is Ty for you Colorado guys. This is really, really well done. Mold set up into injection machine, mold closes, pack and hold. And basically you start with the listing the steps of a process, and then who are the outputs, what are the outputs, and who are the customers and what are they getting? And then you work backward from inputs. What do I need to do to mold set up into injection molding machine? Who's my supplier for that? Another one is sell plastic model kits. So these are some examples. I've seen feed the dog. Actually, I think, did I have that at the top? Nope. I think Sean Hassett did feed the dog, which was really good, especially when you got to give the dog a pill. So this is one, as we go through the PowerPoint, when I start talking about SIPOC, this is what we're talking about. And the option for homework this week is going to be you could do a SIPOC or you could do a swim lane process map. Cook out a turkey. This was, I think, the last class, Eric Hope. And the only thing missing here is a swim lane map. I'm going to have, anytime I have to hand it off to somebody, the process, so it's usually like across departments, like the quoting one, probably, Tyler, got the one you guys are doing. I know Obrick's done a customer complaint one. There's been returns, returning something. When it has to go across different people, it's just there's a way to look at it. And from a lean standpoint, anytime I have a handoff from one department or one person to another, that it's going to cost time, and of course, lean is time management. And anytime I hand off, it's either next day and when, they're going to have it, or maybe a few hours later, or sometimes the weekend, or when they get back from vacation. So the strategy is always, for these kind of things is we map it out and then we say, all right, how do we minimize the number of handoffs? This is purchasing and receiving for Baron Labs. This is Dave Terry. I think he was in last class. Yeah, I think it was the last class. Say a requesting employee, a purchasing agent, a laboratory director, accounts payable person, and there's the swim lane map for that. So again, the homework this time is going to be pick one, either one. Or, I mean, I've had people that sit in the front, they're always the first one on the class, and they do both, but pick one or the other if you like. And we'll turn over to the fun part of our program. Again, about 41 minutes today. I have to probably skip next week. I'm visiting my son that's in the Navy. My wife and I are gonna fly Thursday and come back the following Thursday. So I'm thinking I may have to skip next Monday and pick up Measure Phase 2 the week after. If that's okay with you guys. I'm always shaky on the hotels and stuff. So congratulations, you got 1/5 of the coffee mug already. Wasn't all that painful. Here comes Morgan, South Carolina. Oh, where'd he go? He was on for a sec. So you got 1/5 of the coffee mug, a 1/5 of the certificate suitable for framing. And now we'll get into, here comes Morgan. And quick review of define. We got into what Six Sigma is, history, what are the roles and responsibilities on a Six Sigma team? How do we pick a team? Who needs to be on it? And then we got into stuff like voice of the customer. What does critical to quality mean? We did a little homework on Pareto. And I think one of the stunningest things out of define phase is the cost of poor quality. When you just look at scrap, for example, and what percentage of your total profit goes towards the cost of poor quality. Then we got into some basic Six Sigma metrics. We're gonna get into a little bit more, kind of sneak up on it. And then next week, we're gonna really get into some, or not next week, the week after, we'll get into some real descriptive statistics, which are fun. They're really fun. And then blah, 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 project management basics. Other than, I think the best part of this here is risk management, the failure modes and effects analysis. I think it's underused. It's about, instead of MRB, can we predict and make countermeasures to make sure that bad things don't happen. And then we did a little bit the 14 principles, and that was the lean. So that was your define. And now we're on to measure. So we've defined what we want to do. And now what do we need to do to improve, and can we measure it? Right? That's the most important pieces. And I think it's the most challenging, even doing A3 projects. It's like, all right, that sounds like pain in the neck. How do we measure that? So this is a key. And again, the concept of Nimawashi, which was on the quiz, I believe, is if we do a real slow define, real slow measure, real slow analyze, then improve and control are pretty easy, right? So again, measure is another one we want to be very, very deliberate. This is where, as you help people in your company do problem solving, everybody usually wants to jump to the I, right? And it's just, on the A3 form, just keep everybody on the left side of the form as long as possible. Define, measure, analyze. So we're into the M, and it's about understanding the process, really understanding it by measuring. Because again, Six Sigma is about statistics and making data talk somehow. Otherwise, it just lays in your Excel spreadsheet, doesn't say anything. So we're going to cover today in yellow, easy stuff, process mapping, that SIPOC that I just talked about. I want to go through a unit, take you through the value stream mapping overview. And the reason I want to get into a little bit of detail today, because Albrecht, we're going down to a mapping exercise in Mexico. Marion, we're doing a value stream mapping on the medical studs. And PTA, I got a call last week to maybe help out in Colorado with a value stream mapping exercise, kind of like what we did with IDEX in Oxford. So it just seems to be a tool of the day or tool of the month. And I actually love it. So I'm going to spend some time with it. Then we're going to get into XY matrix, which it's logical. It's kind of a mix between affinity diagrams and the thema. So it's like a group exercise. You're ranking something, and it's basically about cause and effects, X and Y. And then we'll touch on some basic statistics. We'll add to what we know already about basic statistics, and then get into data collection. And then the next class will be, we're starting to do some statistics. And they're pretty easy and pretty fun. Then we'll get into measurement system analysis, including gauge R&R, what's the difference between precision and accuracy, process stability and capability, and that'll be it. All right. So take a deep breath. I'll take a deep breath here. Process definition. And there's different ways to measure. And on our A3 form, for example, it's perfectly okay in that current condition box to have one of these maps. Because the maps, again, especially when you get to value stream mapping, is we're measuring the process. And, in a case of lean thinking, what we're measuring is time. So this is why these are in the measure phase. So process map, let's talk about one first, not the value stream map, but like a swim lane or just a logical process map. It's a graphical representation that shows us how the process flows. And you could pick any business process to do it, paying a bill, hiring somebody, receiving something. There's thousands of processes in our businesses. You could just pick any one and map it out. A lot of times in work instructions, things like that, we will see a map. Describe how the information and materials flow from one business entity to the next, and depicts the input and output of each process step. And in the measure phase, we're looking at the current state, right? Not the ideal state. We're measuring the process. We don't want to do improvements yet, because a lot of times we'll be jumping to solutions, which simply means we might have to go improve it again. And the purpose is to identify complexity. And a lot of times, we've added a lot of complexity to our processes by, handing it off, and then it gets back to somebody else. And then there's, people are entering the same data in different places. I think in South Carolina, when Brendan Shea was there, I think I got Morgan on there. He did a really good job of going through a bunch of different processes where there's such redundancy and wasted time, by people entering the same data over and over in different parts. This is a way to do lean in the office, because a lot of those processes are not as easily seen as walking out onto the floor, and looking at a counter on a machine, or watching how many steps people take, or that kind of thing. So it's very, very sales processes, credit and collections, any kind of those processes, I think they do really well. They're supposed to be living documents. So basically it's the present state. And as we improve it, they should get less handoffs, less complexity, make them as simple as we can. The benefits are we can identify many things. We can look at our process inputs, our X's, and our outputs, the Y's. We could add our supplier requirements, what our customer needs are. Especially when we get into value stream mapping, we can see the value added and the non-value added tasks and steps, things that we can get rid of. Data collection points, like cycle times, defects, inventory levels, cost of poor quality, etc. Decision points and process control needs. So the way we do it is you start with the beginning and the end of the process, and then consult with the process owners. I like to bring everybody together so we can gain agreement on the entire process. I think a great example is Marion's quoting process right now. Again, all the people that own part of that process are part of that team that are mapping it. And then we can observe the process, gain agreement on how the process is actually performed, record the steps, put them in the order of occurrence, build the step information, plot the diagram, and then record and document. And this is kind of an example of one, this is a lot of traffic, kind of like a spaghetti diagram. But if it's too complicated to be covered in one map, then you can break it into multiple maps, God forbid. The swim lane, this is, I think this is an option for the homework. This is the one I usually like to use. I think we did like 60 or 70 people at Ulbrich Steel like 4 or 5 years ago. We had a little workshop and everybody picked a process, and we kind of went through all the handoffs. Again, the only difference with a swim lane map is I have Department A, Department B, Department C, could be job titles, but it's largely the number of times I have to hand off. And every time I have to hand off, you can count on either hours, days, weeks, weekends, maybe sometimes even months of of waiting, the non-value added task of waiting. So a lot of times the strategy is when you do a swim lane map is if I hand this off to Department C, what does Department B know that Department C doesn't know that I have to hand it off to them? And in some cases, it might be something very, very complicated that only Department C can do. But often there's no rhyme or reason to the handoffs, just the way it was set up originally. And then we just added more transactions to the process. Over the course of the years, more people people are buying more. There's more, credit inquiries. There's more and more of it. And the same process that looked good when we were at $1 million in sales doesn't look all that great when we're at 15 or 20. So it's really good to revisit our processes, and you can start with I like to start with any work instructions. That's usually the first thing I ask. You have a work instruction? All right, let's go. And we'll set up a swim lane map. And it makes grade A3, put it on the board, develop swim lane map for quoting. I think we did that. Right, Marion? Those guys?
Yeah.
All right, so another SIPOC, supplier, input, process, output, customer. It's another way to make our processes visual, right? So we can see them a lot easier. We can make decisions better. It helps identify and link different components in a process. And we put it in the measure phase because, again, we're measuring, we're learning about the current state of the process and also defining the scope of the project. Suppliers are vendors who provide either raw materials, services, information. Inputs are the raw materials, the information, the SOPs, the work instructions, the equipment, the services, the people that are involved in the process. The process, now the F is it's a function of, Y is a function of a bunch of X's. So the F of X is the high level sequence of actions and decisions that transforms my inputs into outputs. And my Y's are the services or products that are delivered to their customers or information. And the customers are the end users. And again, keep in mind that many times our customers can be our internal customer who's ultimately using that information or that product or subassembly or whatever. And it has more detailed information than process maps. It demonstrates how each component gets involved. It helps visualize and narrow the project scope. It's another great tool to gain agreement. We talked about the cost of poor quality, and one of the biggest chunks of that waste sometimes, the dollars flying out the door, is what we call hidden factories, where the quality people might tell you, yeah, this is how the process runs, but then you go and see it, and it might be completely different. So this tool is really good to get everybody on the same page in terms of gaining agreement, and yes, this is our process. Okay. It's a great communication tool because again, sometimes we only understand the small part of what we do. It kind of gives you the whole shooting match, and it might help, might have suggestions from someone down the line or up the line in terms of how to improve. And a lot of times we can include our suppliers and customers that are outside the building in a SIPOC exercise. I have a really good example of that with Pratt and Whitney just last week. Maybe I'll include it when I send out the math practice and the slides today and the recording. I think the engineer at Pratt did a really, really good job on it too. But and so we vertically list 4 to 6 high-level process steps, like going to the bar, like Dan did. And you list your outputs first, and list your customers, and then your inputs. So you work from process, and you do all your Y's, and then go back and do your X's. And your suppliers of inputs. This is Sean's, I think. Yeah, this is Sean Hassett's, Joanne and John. To feed my dog, simple, open cupboard. I love this. Get bowl, fill bowl, call dog. All right, dog eats, dog fertilizes, and the customers are the dog, the family, the garden. And the inputs are go shopping, buy dog food, return home, put groceries away in the cupboard, and the supplier's a grocery store. But then someone said during the review, what if you got to give your dog a pill? So that got added on to the process too. So I have, not only am I feeding the dog, but I'm also medicating the dog, and then you got another input, you got another supplier. I think you guys get the point. It's kind of a fun, simple tool. And all right, value stream mapping. This is the tool of the year, I think, or tool of the month. But again, it's another method to visualize and analyze the path of how information and raw materials are transformed into products or customers or services that customers are going to receive, right? And now the only difference between a value stream map and the mapping we talked about earlier is there's a time element here. So there's a lot of counting, there's a lot of measuring time, all right? And we identify, measure, and decrease the non-value added steps in the current process. So we remember non-value added activities are those 8 ways, starting with defects, overproduction, waiting, non-essential processing, unnecessary transport, inventory, motion, etc. Those are non-value adding because your customer doesn't really care how much you do of it. You can't put it on the invoice. So whatever transport and motion and waiting and overproduction we do, we can't have a line item on the invoice for the customer to pick it up. It comes out of your ability to bonus, pay people, reinvest in something. So the non-value added activities are something that gets drawn out of the process as you do a value stream map of the process. And it's said that probably, by taking a process, making improvements, the mapping is a way to see more waste, right? But I can only see so much waste with the naked eye. I mean, there's so many, for those of you guys that read The Toyota Way, companies they'd lean out a process, like let's say our plane exercise, making Lego planes. The world record is 65. PTA holds that record. Well, imagine these Japanese guys going in from Toyota and making 85 planes. And a lot of it is just doing using the tools to see more opportunities, some more seconds, more minutes, more hours of non-value added work. Now, keep in mind that not all non-value added work can be eliminated. And that's usually ISO, quality testing, some environmental stuff, some OSHA stuff. Those are non-value added. And what it means there is my customer's not going to reimburse me for that, but I still have to do them. So the things that are value added, we want to keep. The things that are non-value added, we want to eliminate. And the things that are non-value added but necessary are things that we want to make as lean as possible. So we put the entire high-level process flow from when the customer places the order to when the customer receives the products or services in the end. And a value stream map requires a lot more detailed information than a standard process map. And usually, like the way I like to do maps is a clipboard, a stopwatch, or my phone, and a pencil. I don't need anything much more than that to do it. And it requires going to where the work is and watching and counting. All right. The things we're going to be looking at are cycle time, prep time, setup time, available time, scrap rate, rework rate, number of operators, amount of time that we have to work. I mean, in terms of demand. And it all fits onto a nice, neat map like this. This is the book Learning to See, which is kind of like the Bible for us lean knuckleheads. It's been around since, 30 years I've been doing lean. And largely it starts at the top right. This is where my customer is. The customer is State Street Assembly. In this case, the requirement is 18,400 pieces per month. And not only that, they want 12,400 left ones and 6,400 right ones. And each batch of a tray is 20 pieces. I have 2 shifts to work. So largely when we start the map here with the customer, and it's going to be available work time. And this is where we're going to come up with something we call tack time. And tack time is always going to be available time divided by demand. All right. So in the case of the guys at Marion, at 13.9 million pieces divided by 6 hours a day times 20 days in a month, And it's either probably gonna be in either the units of pieces per, probably, I mean, I'm sorry, minutes per 1,000 pieces or something like that. So it's always gonna be time units divided by demand. All right, and the available time is, all right, it's my workday minus my lunch breaks, minus my breaks. If I have 3 shifts, then it's gonna be maybe 6.5 hours times 3 shifts. That'll be my available work time. Whatever units I decide to put here, whatever units I decide for tact, it could be seconds per piece, minutes per piece, hours per pallet. Whatever we decide, we're gonna use the same units throughout the whole map, okay? The way the map is laid out is that's the first order of business is to get that right, in terms of understanding demand. And then information flows from our customer from right to left. And this is how do we take an order? Where do we put it? How does it get onto the shop floor? In this case, got 90, 60, and 30-day forecasts that they work with. I discourage you, other than Ulbrich, probably from doing forecasting, because usually they're wrong. Something changes usually after especially 90 days out. And then I produce a daily order based on a forecast maybe, or, I got my forecast, plus I got things that squeeze in there. It gets into some kind of MRP, whether it's a Job Boss or you name it, whatever you're using. And then you got it goes to our supplier all the way to the left. In this case, Michigan Steel. They need 500-foot coils, and that's sent by tells you how old this book is, a weekly fax, right? And then the truck comes. You'll see icons like a little truck, like this. They deliver on Tuesdays and Thursdays. And then a key piece here is these little triangles. Sometimes I've seen people use, instead of triangles, this means inventory, the triangles. I've seen people use tombstones here for that, which is just as good. And again, in inventory, before stamping, I have 5 days here. So now even turning my inventory into time units, number of days in this case. All right. And then, just like those of you guys have done the plane exercise with the Legos, each one of these steps is represented by a dialogue or an information box. So I have stamping. What? Yes, Morgan, our first question of the whole semester. What's going on?
Yeah, I just kind of wanted to ask about this because I've made attempts to do value stream maps, and here you've only got like a continuous flow at the beginning. But when you start to get into like semi-continuous processing, and it becomes difficult to get a specified value on those inventory levels, how would you handle that situation?
Yeah, I think, a lot of times, especially when I have a lot of components that, my inventory is comprised of a lot of different things. You're going to use Pareto. So 20% of those items and represent 80% of the value there.
Okay.
So you're talking about coils?
Yeah, we
Partial
have,
coils in each step.
it's spools, but yeah, similar concept. We'll have, like an intermediary spool between stamping and that S weld one that's indeterminate length.
Right. You have a product like an SKU number for that intermediate coil?
Yeah,
Yeah, so you would have an inventory on that somewhere, right?
yeah.
I mean,
So
what the cool thing, Morgan, is this is what we're going to do in Mexico in November.
yeah, I guess I was just this seems to work really well when you've got like a process that's for a single component that is discrete. I don't know. I guess I just struggle how to apply this in, more job shop environments.
I would pick, a process that, like, for example, at the mill, for example, the nuclear process, where there's a ton of handoffs, a ton of steps, a ton of, 100% inspection, where the actual value added work is only, when you add it all together, can be measured in hours or days, but the lead time is actually, we mapped it, is 39 days. So 39-day production lead time, value added work, 5 or 6 hours.
Yeah. So I guess my point is that this really only works for a specific product.
Yeah, it's not like it's very difficult because again, I had the same exact issue because I'm looking at State Street Assembly, when I first learned about this, and I make epoxy paint or urethanes, or and like so. Okay, how does a pail here and a pail there, and I have like color packs in between each step, things like that. So it doesn't like it's not like you can follow a blueprint on how to do it. It definitely takes a lot of, and I think the best one I've done is probably with PTA in Oxford. I know Rob's on the call with that Cat 1 line. Because again, same thing. I got different inventories coming from different molding machines, getting assembled in a certain place. Things got to get delivered to the cell all day long. So it's like, I like to pick a process that you're struggling with. I don't know if I answered your question. I'm not.
No,
Let me-
no, you definitely did. I just think I've been trying to use this tool for assets instead of products.
Yeah, and a lot of times too, Morgan, it's definitely a group activity. It's not something you can really do by yourself, I don't think. And I think a lot of it is, the book is, if you just look at State Street Assembly, that's what the whole book is about. And you're saying, all right, what the hell does this have to do with us, with me? So it's like kind of like practice a little bit with it with groups. So for example, I'd get somebody from, I think we're doing that in Mexico. You can get the buyer involved. You're going to get somebody from receiving involved. We're going to get somebody from each operation involved and kind of go through the flow and try to create some flow with it. And then these dialogue boxes, now that Morgan mentioned it, they say, well, there's cycle time, there's changeover time, these may not work for us. You know what I mean? These may not be the things that they're important in this box. It could be something different. So it's again, this is like the way it's laid out. It's like a general backbone of how to do a map. But I think you're right. It's definitely has to be tailored to each process. I don't know, gallons per minute, pounds per minute. In the case of Marion, I think they got to ship 13 million of these parts per month. Well, what are the units there? They do every 1,000. I think Sal's on the call. That's what we talked about, or weight even. It's like the key thing is, all right, how do I start to apply time units through the entire process, including the information flow? So, did I answer it? I hope, or not.
Yeah, definitely.
All right. So again, these are once it gets onto the floor, and again, your ingredient, like your supplier. I can't do every supplier. I can't do all my resins, my pigments, my whatever. I have to pick the ones that are 20% of them that represent 80% of my buy, and that's what would go into this first triangle is my inventory in I'm in time units, right? So I have if I do like stock days, or if I do how many turns I have, there's a healthy number based on your sales volume of both the number of turns my inventory should have every single year, and also the average number of stock days. How long on average, do things stay in my inventory? One of my customers is 93 days on average of the average amount of time something sits and waits in inventory sleeping. So that's one of the ways. I think it's important, especially as you're in an election year, or like the things that have happened over the course of the last few decades: 9/11, 2008, COVID. It's this is money that's sitting in these triangles that you're not going to be able to use because they're sitting there. So it's something that you usually want to pay special attention to. But then you just line up your processes one after the other until we get to staging and shipping. And then we ship it out the door to State Street Assembly. And the faster we can do this, the more profitable we are, right? If we could figure out ways to make this we're not working on the same job for long periods of time, we're much more profitable. Let's see, next slide real quick. Yeah. So when you add up all of the times, for example, so I add up stamping, welding 1 and 2, assembly 1 and 2, and shipping. my production lead time from the time I get the order to the time I ship it, in this case, this is obviously just state treat assembly, which is made up, is about 23.5 days, when my actual value added time, where I'm transforming the order into something I can ship and get paid for, is actually 184 seconds. And this is very, very typical of what you get from a value stream map. All right. Back to Rob O'Connor, PTA, using the mapping process, they were able to, we mapped out the Cat 1, and it went from 13 assemblies per hour to 36 with the same number of people, by eliminating most of the 8 waves that were in the process. But and you got to see it by doing a map like this. This allows us to see, what do we attack?
Yeah, it's a pretty cool process. We got to, identify the bottlenecks and go
Yeah.
from there.
Yep, and you can see overproduction, right, Rob? Like I could say,
Yeah,
I
it's
can't,
all time, data, cycle times, how long does it take to make a box, stuff
Yeah.
like that. Everything adds up.
it's very similar to the nuclear process too at the mill. It's like, it doesn't matter how fast stamping runs if welding number 1 is slow. I can't work any faster. So I got to make sure that everything is timed out, and I try to come as close as I can to flow. Inventory is a big piece of it too. If I have loads of inventory between each process step, I don't know how many defects are in there. I don't know how, it's inventory is a killer sometimes. I don't have space in the cell. One of the things we did in Chicago, I think got my Chicago guys on, I think so, with the new one, or the new machine, was, you know what? There's no more than 8 or 10 coils before it. Not just an unlimited number, not 50, not 40, but setting it up like, 5S wise, of this is where the input comes, and this is it. This is the max, no more. Cool, really cool, powerful tool. This is a lot simpler tool. Any other questions? Thank you, Morgan. Thank you to Rob for kicking in there. Anything else question wise for I know we're gonna be doing a bunch of this, so in the future. I really starting to like it. I used to hate it, but I think it's fun. And I think I hated it because it's not, I think what's kind of what Morgan said. It's not all that intuitive. You really got to kind of get a little bit creative with it in terms of how we're measuring things. I mean, setups is one of the things, right? There's a space for changeovers here. That's setup time.
I think with me, it's just like collecting the data.
Yeah.
Collecting the data is very time consuming sometimes.
Yeah,
Depends on what tools, what resources we have, and stuff like that.
And this is a much simpler tool called a spaghetti chart. Probably heard of this. This is actually Atlas stamping. So you can see all the movement, the flow, materials, information, and people in a process. It can reflect the distances between multiple workstations, the physical flow. Again, and this is all kind of in feet. So you can see the process starts here at the material crib. It goes 42 feet to a blanking machine, then it has to get marked. Then it has to move 48 feet over to another station. Then it has to go and get the bird. Then it has to go to in-process inspection. Then it has to go to quality assurance. You can see that in the end, there's 270 feet. Fairly small plant, but by having the in-process inspection more, moved. There are a bunch of decisions that were made based on making the process visual in terms of how much movement there is. And a lot of times they call it a spaghetti diagram because of what it looks like when it's all said and done. This is batch record movement. And then you analyze the chart. A lot of times, if you start to map something in the office, particularly, and the amount of steps, and you put the pedometer on someone, track steps, you'll find that you're paying people to walk, hundreds of miles or dozens of miles a year. This happened when we were out in Illinois for that Kaizen event. Just how much, 2 shifts, 4 people, how much they had to walk to a printer, and it ended up being like almost a full work week of just walking. You know, so I mean, really easy sense to to pay for a $300 or $400 wireless printer and put it closer to them. You know, these are the kinds of things that become very apparent, because don't forget, those printers were in that location for 20 years or more, 25 years. No one even thought about them. But then you start saying, okay, how many steps? You know, 2,000 steps to a mile. People walk about 2 or 3 miles per hour. Well, I can determine, you know, what are we paying? What's the cost of poor quality there in terms of what we're paying just for people to walk? And then they complain about, you know, they're saying, hey, you know, it was up down the stairs. So it was down the stairs to a printer. You know what I'm talking about? Who's on there? John Pirelli?
Yeah, I remember that from the A3, they
Right?
discussed it.
Yeah. And they ended up moving them, right? They ended up just changing where the printers were, and yeah. But that's a spaghetti chart. And then the XY matrix. This is a cause and effect matrix. So remember, the key formula is Y is a function of a bunch of X's, right? So my Y is what I want out of the process. And it's usually 3 to 5 X's, critical X's. If I can control those X's, then I can get the Y that I want. And the good news there is it's usually not 100 X's. It's usually vital few, they call it, 3 to 5, that we got to figure out what do we measure. And if we control these X's, we're going to get the Y that we want, right? So we're going to focus on the X's with the greatest influence. And this tool is to help us identify the XY matrix. I wrote down the bottom, I actually did that right before class. I kind of feel like it's a mix between affinity and PFMEA. And what I mean by that is, if you remember affinity, it's kind of like a brainstorming session where everybody's kind of putting on, like, what are the reasons why people are late to work, for example, you know, on sticky notes, putting them on the board. This is definitely not a tool that you can sit in a cubicle and do alone. You know, this is, again, perfect for an A3 team, you know, 3 to 4 or 5 people. And it's like PFMEA because we're going to start to grade. Remember, in PFMEA, we looked at what's the likelihood of occurrence, what's the impact if it happens, and how easy is it to detect. And we did a scale of 1 to 10. Well, this is very similar to that. It's kind of subjective slash quantitative. And this is what it looks like. So I have a list of all my input variables, my X's. All my Y's go across the top, what my customer wants out of the process. I have a weighting scale, you know, so as I'm probably just going to show you the next slide just because it's a lot clearer. But basically I'm going to take all those possible X's and link them with the customer requirements. And then based on a number, 1 to 10, we're going to multiply them all together and come up with a ranking. So it's very much like the FEMA. And this doesn't help a lot. Here's the input variables 1 through 7. Here's the output Y's that we want. What's important to the customer. And then as a team, you're going to say, well, I think that's a 3. I think that's a 9. And then again, having the customer here, you know, as a voice of the customer, or Joanne and John, you know, you're the voice of the customer, really. You know, so to be on A3 teams and doing stuff like this, I mean, there's nothing like having, you know, you guys in the build. I have the customer inside the building, you know, so it's like, it's perfect for doing things like this, because you are the voice of the customer. It's like perfect. Here's an example, the voice of the customer for IT help desk. The voice of the customer is, I want fast and easy to get help. When I need it, I don't want to wait all day. I don't want to wait till next week. I want to have more knowledgeable agents. I don't want to talk to somebody that doesn't know what they're talking about. I don't want my PC down very long. I want my PC to go faster. I want better communication on changes. So here's some improvement ideas. You could add some phone agents, have more help. I could have more desk side assistance. I could improve self-service portal, you know, where people can go and help themselves. I can train my agents better. I can have the thing self-heal. You know, I could publish a newsletter once a month and, you know, everything you want to know about your IT. And then you basically take each of those and say, all right, let's rank them from 1 to 10. And then you multiply, for example, self-healing for known problems, fast and easy to get help is very important to the customer. More knowledgeable agents is a 3. And it's again, it's very subjective like the FEMA. And then largely I'll just take the 10 times 5. Because these are the customer priorities ranked from 5 to 1. I take 10 times 5, that's 50. 3 times 4 is 20. That's 70 total. Plus 13 is 83. Plus 10 more is 93. 10 times 2, I mean, is 20. So I end up with 112 for that particular. So very similar to FEMA. And then the first thing I would do probably is, or consider, is how I could do more self-healing. So that's that. Some basic statistics for a few minutes, just to touch on it. And this is probably, this is something I'm going to ask you like church every single class. Because I do have, some, I have Joanne and John in this class. There's 2 different types of data, continuous and discrete. And all you need to remember there is continuous data is things that we measure. Discrete data is things that we count. All right. And a lot of what most of us are using is continuous data. We're measuring something. Discrete data are things that we count, like pass, fail, yes, no, votes, polls, things like that. There's different types of measurement scales. I'm not going to go spend too much time here. One is nominal, and that's descriptions about categories and names and labels only. No ordering scheme is possible. So a bag of marbles has 11 yellow, 18 red, 3 orange, 5 green. The central location, which we're going to get into in our next class, is the mode, which is which one is in the middle of the population. It's for information only. Don't spend too much time thinking about this, because this is just bogs my mind. Ordinal ranking is differences between values cannot be determined or meaningless. For example, product defect by type. And then there's interval, where we have equidistant data arranged in order. Differences can be found. What we're really going to focus on is ratio, just for information. There's nothing on the quiz, but just to let you know, there are 4 different types of measurement. Population and parameter. We're going to talk a lot about this. All possible observations of similar items from which a sample is drawn. We're never going to be looking at populations. Just keep in mind, like, let's say for example, I want to know the average weight of whales in the North Atlantic. Well, obviously, I'm never going to go out and get the population, right? I'm not going to weigh every whale in the North Atlantic. So a lot of what we're going to be talking about is sampling, how many samples I need to draw a good conclusion about the weight of whales in the North Atlantic. And a parameter is the arithmetic description of a population value. It's often estimated by a statistic. All right. And a statistic is maybe the weight. A sample is a randomly selected set of units, values, or items taken from the population. So if I want to get a really good statistically significant idea of what whales weigh in the North Atlantic, I need to figure out how many I need to get to weigh. It's not going to be the population. It's not going to be all of them. All right. And then statistic is a numerical value taken from a sample data set that can be used to make an inference. So after we've sampled, now we're going to look at a bunch of different statistics, whether it be the sample average, the mean, or maybe the sample deviation, standard deviation. And that's kind of what we're going to get into next, is a lot of these statistics that we can use that can tell us something about a population. The population we're going to use a lot for ha-has for the next bunch of weeks is going to be my weight. Basically you're going to see 800 weeks worth of weight I weigh myself on Friday. I do my blood pressure and I do my pulse rate every single Friday. And obviously that's nothing more than a sample, right? The population there would be, I weigh myself every second, right? And I'd have that 10,000, I don't know, 1 million readings, but I have to sample somehow. So I have some sampling parameters. Friday, I'm going to get my data, my statistics, and then we try to make the data talk. A lot of statistical notation, and we're going to go through these, different parts of the class. I think this slide itself, you'll see it as we go, different parts. I wouldn't get too concerned about this either, because a lot of what we do in terms of calculation isn't longhand. Mostly it's a couple of mouse clicks. And guidelines for data collection, what do we want to measure? What characteristics do we want to measure? Make sure we have the right tool and techniques, and we're going to get into a tool called Gauge R&R to make sure that our sampling is right. Who's going to collect it? There's different types of sampling methods that we're going to talk about, and who's going to analyze and report the results. The two types of sampling are random and stratified. So random is every part has an equal chance of being selected, and they have to be representative of the lot. Then stratified sampling is a subgroup of data that reflects a population parameter. For example, what is the mean height of children in the 3rd grade? So the subgroup of data is actually 3rd graders, and we're going to sample from that. That's it. Done. Next week, we'll get descriptive statistics, fun part. And following week, we'll do precision accuracy, gauge R&R, and all that. So we're 1/3 done with Measure. I'll send you the slides, recording, math practice, and I think I'm going to include that SciPoc that my friend at Pratt did. You can see, I think it's really good. I'm going to ask him if I can send it. Anything, guys? Anything else? Questions? Thank you for the question. I really appreciate it. Morgan, Mr. O'Connor. Have a great night, y'all.
See you, Bill.
Thanks, you too, Bill.
Take it easy.
guys.
Good one,
Bill,
Bill.
you too.
Have a good one.